SOHCAHTOA. Okay, now what we're going to do is we're going to translate that to x, y, and r. So in order to do this, you have to know the diagram and how this works. So I'm going to kind of lead you through these definitions. I've given you these definitions in terms of x, y, and r, and you need to have that down before Wednesday's quiz. But if you got the SOHCAHTOA stuff down, it's the same thing anyway. That's what I want to prove to you. So what I'd like you to do in the diagram, just put a point and label that P. And that, of course, any point has an XY value. So what we're going to look at is we're going to look at a point. Whenever you have a point, you can get the trig functions based on that point. So what you want to do is you want to draw a radius and label that R. That's the radius. Okay. Then you want to basically label that as theta. That angle would be from the x-axis to the radius. And then you can go straight down and make a right triangle. Okay. So based on what I have here, that would be x, because you're over x when you plot the point. This other part right here would be y. So see, since you already know the SOHCAHTOA stuff, then translating it in these definitions isn't any different, because that's the setup, okay? And what happens in trigonometry is you always kind of have a circle going around that point. Okay, we'll kind of get into the unit circle a little bit in the next class, and kind of start going that way. So here's how this basically goes. And see, if you look at this diagram, you already know this. The sine is opposite over hypotenuse. So if you look at my diagram, what's opposite? Y. What's hypotenuse? R. So it's y over r. Okay? The cosine is adjacent over hypotenuse. So if you look at my diagram, what do you have? Adjacent's x, hypotenuse is r, so that's x over r. Okay, tangent's opposite over adjacent, so you would have opposite y over adjacent x, so that's how you get y over x. So see, if you look at that diagram, if you've got the SOHCAHTOA definitions, the right triangle definitions down, then it's a pretty simple matter of just translating those over. But you're going to use this enough that you want to get these memorized as fast as you can. And then remember, we learned that the sine and cosecant are reciprocals, so that's how that goes. Secant and cosecant are reciprocals. Tangent and cotangent are reciprocals. So sometimes in some trig books, they start this way, then go to the triangles. Our book goes triangle, then it goes here. Same idea. You're both basically using the same idea. Okay? All right, so a couple of observations, and then we're going to just do some problems to kind of help us learn these definitions. So what's the reciprocal of the sine? Okay, this is the kind of stuff on your Wednesday quiz. I'll just point blank. I'll say, what's the reciprocal of this? You need to get all that stuff down ASAP. Tangent is cotangent. Okay, now the value of r is always a positive number, and that's because it's a radius. Okay, so it's a radius of a circle. So that's another kind of important aspect on this is x and y can change to negative and positive depending on what quadrant you're in. But r is always a positive value. Okay, now if you look at this diagram, you should already know this. How do x, y, and r relate? After all, it's a right triangle, so how do they relate? X squared plus y squared equals r squared, because it's the Pythagorean Theorem, right? Okay, so what you're going to get is x squared plus y squared equals r squared. So that's coming from the Pythagorean Theorem, which we've already dealt with. Okay, so what we've been doing is a squared plus b squared equals c squared. Well, I'm just changing the variables. It's still there. Okay, does that make sense? Okay. Now, what we're going to do with this a little bit is on this next page, there's a couple of things we're going to look at, and the purpose is to help you understand the definitions and what they're saying. Okay. So as we go through this, we're going to just draw a diagram on this point, then we're going to find the values of the trig functions. Okay, so the first thing that you would want to do on this example is let's just draw an xy axis, okay, and you want to plot the point 9, 12. Now you don't need to go 9 notches and 12 notches. You don't need to take the time to do that. Just think of that as 9. You're going over 9 and you're going up 12. So your point is over 9 up 12. You're in quadrant 1, right? The point is that. Now, in these problems, all you have to ever figure out is what x is, what y is, and what r is, okay? And then you go to your definitions of the trig functions, then you got the answer easily. Okay, so what's x? What did I give you? 9. What's y? Okay, so I got to give you that. So x is 9, y is 12. How do you find r? Pythagorean theorem, right? Okay, so we have x squared plus y squared is equal to r squared. Okay, and a lot of times these turn out to be whole numbers. We call that a Pythagorean triple. Sometimes they don't. I think this is a Pythagorean triple. So you'd have 9 squared plus 12 squared equals r squared. Okay, use your calculator if you need to. This is 81 plus 144. Okay, let's see. If you add those two numbers, I think you get 225. Okay, then what? Square root of both sides, then that's 15. Okay, so you would end up getting r is equal to 15. Okay, so that's the information we need to get this, to write down the definitions of the trig functions. See, I give you x, I give you y, you find r by the Pythagorean theorem, then you go your definitions. So what you want to probably do on here is just go ahead and draw this diagram like this. So you would have r is 15, and then if you look at your triangle, you would have this side of the triangle would be x equals 9, and then this side of the triangle would be y equals 12. Okay, so now you can get everything put together, but what you're trying to do is you're trying to transition to these definitions, and then that's your angle theta right there. Okay. Okay, now see if you got the SOHCAHTOA down, then you can figure these things out. Okay, so I'm just going to do this like this. The sine is y over r, that's the definition. The cosine is x over r, and the tangent's y over x. So now we got everything that we need to know. We plug in, we reduce the fractions, and all we're doing is getting the value of these trig functions to help us learn this. Okay, so what is the sine? 12 over 15, right? Okay, and we'll reduce it in a minute. What's the cosine? X over r, that's what? 9 over 15. Okay, what's the tangent? 12 over 9. Okay, just plug in because I got everything written down here. X, y, and r, you plug in. Then you're just going to reduce these fractions, which you can reduce in your head if you want to. I don't care. You're really dividing that by 3 over 3. So you're going to end up getting the sine is 4/5. So that takes care of that. Okay, you can go to the cosine. Again, just divide by 3. And if you do that, you're going to get 3/5 for the cosine. Okay, then you can do the tangent. Again, you can divide by 3. Okay, so it looks like that's going to give 4/3 like that. Okay, so you guys understand what I did okay? Now, the other thing from here is which trig function is the reciprocal of the sine? Cosecant. You need to get that down. So the cosecant would be 5 over 4. So once you get the sine, the cosecant's a piece of cake. You just do that. What's the reciprocal of cosine? Secant. So the secant of theta would be 5 over 3. Okay, so we have that. And then the reciprocal of the tangent is the cotangent of theta. So that'll be 3/4 like that. So that's how you're doing that. So the purpose of the activity is to let you see how a point relates to the trig functions. Okay, I have to give you x and y. You have to find r, and then you got to know the definitions. That's it. Okay, does that make sense? That to me in trig is one of the more basic things that you learn how to do with your definitions. Okay. All right, let's do one more here. I'm going to kind of help you start this, and then I'll let you finish it up here. Okay. So again, let's do a diagram. When you're doing your homework, you don't have to do a diagram. You find x, y, and r, and you plug into your formula. What quadrant is this point in? 2, because you're going left 9, and you're going up 5. Okay, so it'd kind of be going like that. So your diagram would go like this, and you have that point -9, 5 like that. Okay, I do want you to draw the diagram just for your notes. So if we go straight down, theta would actually be that angle. It would be the quadrant 2 angle. Okay, it's still, the definitions are still the same. It's not this angle. That's called a reference angle. That's a little different. Okay, so what we have, let's just write down what we have. We have x equals -9. We have y is equal to 5. So I'm going to let you guys kind of take over and get this done. I'll put the definitions up here. You need to go ahead and find r, and I think you'll have a square root. Okay, so you need to go ahead and use the Pythagorean theorem to find that. Okay, go ahead and do that. And then I'll write at the side what the definitions are, and then we'll see if you got those, get this put together. You do have to rationalize denominators too. And this kind of problem right here is a guaranteed first test question because it's real fundamental stuff that you want to know how to do. I give you a point. Without a calculator, you find the 6 trig functions. So you have to know the definitions, know the Pythagorean theorem, know how to rationalize denominators, essentially. That's the idea. So go ahead and take it from there. I'll give you a couple minutes to see if you're on the right track. And then we'll kind of proceed from there. What are we getting for R, by the way? That's the first thing you want to make sure that you get. What are you getting on that? 81 minus 25, which is what? No, okay. Because you'll end up oh, hold on. You got, I said the wrong thing. It should be 81 plus 25 and do that square root. Okay. So you would have negative 9 squared plus 5 squared. So that is 81 plus 25. So you get R squared equals 106. And then you square root both sides. So you would end up with R is equal square root of 106. Okay. So this is what you come up with. And once you come up with that, the rest of it is, do you know the definitions? Do you know how to rationalize a denominator? Okay. Everybody got that okay? Okay. So then what you would do is the sine would end up being 5 over square root of 106. Okay, and I'm going to just write it that way before I rationalize, and I'll show you what I do. The cosine is x over r, so that's negative 9 over square root of 106. Okay, the tangent's y over x, so that looks like that's 5 over negative 9. Okay, now what we're going to do is just do the reciprocals. Now I want this to be rationalized. Before you rationalize it, I would just go ahead and turn that upside down. So then you would get the cosecant, and then you got that in the right form. So that's what you should get for the cosecant. Okay, the secant, I would just turn this upside down before I rationalize it. So that would be negative square root of 106 over 9. And the negative, it doesn't really matter where it is. The preferred way is just put it in the numerator like that. So you'd have that. And then the cotangent is just going to be negative 9 over 5. Okay, then that leaves you with just rationalizing the denominator on the sine and cosine, then you got it. Okay, does everybody see what I did okay? Okay, right. Now what we do here is, and you can rationalize in your head, you're going to do it enough times this semester that you'll start just processing that in your head. So what you get is 5 radical 106 all over 106. So that would be your answer to your sine. Okay, and then the cosine, same thing, multiplied by root 106 over root 106. And what you would get there is negative 9 square root of 106 over 106. Now we've got all the answers to the problems right there. Okay, so what we would ultimately be looking for is the sine in a rationalized form and the cosecant in a rationalized form. Okay, the cosine rationalized, the secant rationalized, and so forth like that. Okay, so the hardest part of the problem is just finding R to me and then knowing definitions and rationalizing. That's what you got to do. Okay, yes?
Would you read Mark
Say it one more time. I need to be closer to you. If you didn't round. Oh, rationalize, okay. Yeah, that's the standard part of what you do. Get used to doing it, okay. So, and like on the test or something, I'm going to state that just to make sure you do it, okay. I'll put that on there, okay. But you're going to do that enough. Rationalizing, there's a lot of reasons why we do it later in the class or in calculus, so you want to know how to do that now, okay. Okay, let's do one last thing here. Go ahead. Do you have a question?
Yeah, I was going to ask if you're explaining why the table is the...
Okay, that's by definition. Okay, by definition. See what you're going to do. Anytime you have a point, we're looking at an angle that's in standard position. Remember, standard position means x-axis to whatever ray you're talking about. So no matter where your point is, you're always going to be measuring from there to there. Yeah, okay. Now it's going to turn out that if you did the trig functions of that angle, some of them would be the same, some of them would be opposite by a sine. That's called a reference angle, so we're not worried about that right now, okay? So if you were in quadrant 3, then the angle would be from there to there, and so forth. It's a standard position angle by definition, okay? Yes?
One more thing about the angle. So theta, we're looking at theta in relation to like how close it is to the y-axis.
Remember, standard form. Okay, what's standard form of an angle? Starts there at the x-axis.
But which one, like, are you looking at the angle above or below?
You're talking about the positive and negative one?
The angle on the triangle.
You're talking about, this is the angle we're looking at, not that.
Okay.
This angle right here, that little one is called a reference angle. You don't look at that. You look at
Could you draw the triangle?
from x-axis to there.
Could you draw the triangle, just like, a visual?
Yeah, if you drew a triangle here, it would go like this. And what you'd end up having is you would have x is equal to -9. You would end up having y equals 5. And then your radius would be square root of 106. Okay? But the thing is that by definition, we're not looking at that angle. We're looking at that angle. This right here is called a reference angle. So we don't look at that. Now, ultimately in this problem, it just means find x, y, and r. So if you found x, y, and r, you would get the same answers. Like if you went ahead and did sine is opposite over hypotenuse, you'd still get the same answer. But technically, in the definition of trig functions, you're looking at an angle that's in standard position.
Sure.
Okay? Sure. That's the idea. I mean, it doesn't really, even if you didn't know that, all you got to think about is if you know x, y, and r, then you got it. Okay? So, but the angle technically is the quadrant 2 angle on that. Okay? Okay, so let's see. Let's do just, I think we'll have time maybe to just start this one thing here, kind of get you this definition. So we're going to look at what we call quadrantal angles. And you need to know this vocabulary. Another thing you got to know, quadrantal angles are just things that are on an axis. So you could have like 0 degrees, 90 degrees, 180 degrees, 270, and of course the angles go on forever. It's just you're on an axis. So your point terminates on an axis. So what your goal is to be able to, in your head pretty much, figure out what the 6 trig functions are of any of these angles without having to touch your calculator. So I'm going to get you started on that kind of today and kind of show you what this means. Okay, let's go ahead, and I think we'll probably have time to do maybe 2 of these, or maybe just one of them, the radians. So when you go to this next page, here's what you want to do to figure this out. We're going to look at 0 degrees, 90 degrees, 180 degrees, and 270. We're just going to use those positive angles like that. Okay? Now what you're going to do is you're basically just going to you could let r be any number you wanted to except 0. It's got to be a positive number. But to keep it simple, the best way to do this problem is just let r be 1. Okay? Because it's simple. Now what I'm going to get you through is kind of what these points are. So if you were at 0 degrees, your point would be on the x-axis. And what you would end up having is your radius right there would be 1. Okay? R would be 1 because I decide to let it equal 1. Now what you need to tell me is what is the x and y value of that point? What is it? You're over 1, right? So what is x? 1. What's y? 0, because you're not up. Okay, don't memorize that. You need to understand that. If you let r be 1, then that point becomes 1, 0. So in this situation, you would have x is 1, y is 0, r is 1. And that's all you would have to do to figure out the 6 trig functions is know x, y, and r. That's the idea. Okay? Well, let's go to 90 degrees. So now your point is there. And again, we're letting r be 1. So the radius is always just the distance from the origin to that point. So what would this point be? 0, 1, right. It's up 1. It's not over, so it's 0. So in this case, you would have x is 0, y is 1, and then r is 1 like that. Okay, that'd be the idea. Okay, now you go to this point. Okay, we're now to 180. Okay, so again, the radius is 1. So what would this point be? Be careful with your signs. It'd be -1 because you're going to the left, and then 0. So in this case, you would have x is -1, y is 0, r is 1. Now see, that's what you got to know to find the trig functions. You got to know what x, y, and r are. Okay, so that's how you figure it out. And then finally, if we went to 270, okay, and the radius we chose to be 1, what would that point be? 0, -1, right? Okay, so that means you would have x equals 0, that's x, y would be equal to -1, and then r is 1 because we let it be that. So really what you got to do, if you're finding the trig functions of what we call quadrantal angles, you just let r be 1, and then you can figure out those points, okay? So let's finish by just doing the 0 radians, and then that'll be a good stopping point. And we can look at the diagram that we already have. So if you're doing 0 radians, this is what you'd be looking at. Okay, you would actually be looking at the point 1, 0. Okay, so you would end up having x is 1, y is 0, and r you let equal to 1. That's it. Okay, now the rest of it is just applying these definitions to work them out. So the sine is going to be y over r. Okay, so that means that is 0 over 1. So that means that is going to be 0. So the sine of 0 radians is 0. Okay, if you go to the cosine is x over r. So that would be 1 over 1, which would simplify to 1. So it turns out the cosine of 0 radians is 1. Okay, the tangent is y over x. So y is 0, x is 1, 0 over 1 is 0. So the tangent of 0 radians is 0. Okay, you guys see what I'm doing? So I've just got to use the point 1, 0 because I let the radius be 1. If you let the radius equal 5, you would get the point 5, 0, and the ratios would still reduce the same way. Okay, so now I just do reciprocals. So what is the reciprocal of 0 over 1? It'd be 1 over 0. What do you know about that? It's undefined. So the cosecant of 0 radians is undefined, and you'll get into that some. Okay, the secant would be the reciprocal of the cosine, so that's still 1. Okay, and then the cotangent would be the reciprocal of the tangent, so you would do x over y, so that would be 1 over 0, so that's also undefined. So what you're going to find on these quadrantal angles, I mean, that's the way you figure this out in your head, is if you know the definitions and know that point, you can figure them out. And what happens is they have a pattern. Notice I have 2 zeros for an answer, 2 undefines, and 2 ones. That's the way it will be. If you go to 90, you'll get the same thing. If you go to 180, well, the ones will probably turn into -1 and so forth. So we'll continue this a little bit next time. The idea is you want to know how to figure out this at any angle that's on a quadrant. We call that a quadrantal angle. Okay? Remember, it's all about finding x, y, and r. Try to keep the stuff simple. If you're finding a trig function, you got to figure out x, y, and r. If you do, you got it made. Okay, that's it. Okay? All right, if you didn't turn your paper in, you bring it up or you email it to me before midnight. If you do, make sure I can read it.
Professor,
Yep.
I have a quick question.
Sure.